We know about the ideal gas law, and we know about the van der Waals equation. The first makes assumptions about a gas that may or may not be valid depending on the pressure and volume, whereas the second does not make these assumptions, which means that a calculation using this equation will always be at least as accurate and sometimes much more accurate than when using the ideal gas law. But why don't we go ahead and do a calculation with each of these equations so we can really see the difference? Let's say we have a 4.25 liter container holding 3.46 moles of carbon dioxide at 229 degrees Celsius. What is the pressure of this sample? First, let's use the ideal gas law. This will be an easy calculation. We just rearrange the equation to solve for pressure and then plug in all the data, making sure to use a temperature in Kelvin. 33.5 atmospheres is what we will get. Next, let's use the van der Waals equation. This will be slightly trickier, but still not too bad. First, let's rearrange the equation to solve for pressure by first dividing both sides by V minus NB, and then subtracting the N squared A over V squared term. Now, given the data we already have, as well as the two additional variables for the van der Waals equation that are specific to carbon dioxide, which we can get from a table of values, let's plug everything in. Doing all the arithmetic and being careful with our order of operations, we will get 32.4 atmospheres. How do we interpret this result? Well, the 32.4 we got with the van der Waals equation will necessarily be more accurate, and it looks as though the ideal gas law gave a pretty reasonable estimate. However, the difference wasn't immense because we are not dealing with an exceptionally high pressure, though well above atmospheric pressure, and also because carbon dioxide molecules are nonpolar, so the attractive interactions won't be incredibly significant. If we pressurized further and replaced with a polar molecule like water, we would see that the ideal gas law would become less and less accurate at predicting things about this system, because the two assumptions that are corrected in the van der Waals equation become more and more significant. Now we have a firm quantitative understanding of the differences between the ideal gas law and the van der Waals equation, and the different kinds of conditions we might want to use one over another.